want you to watch. The first is a clip from Family Guy. It's kind of a joke about orbit, but I'll ask you some questions to actually think about what they're showing. And then there's another short video about Rube Goldberg, the person. And so just take about 8 minutes to answer those, and we'll come back together to review. So 8 minutes. I'll be here listening if something doesn't work, if you're not sure what to do. But just work on do now. Go for it.
Mr. Haight?
Yep.
Kenson says he couldn't hear you, so he's going to like leave and then come back.
Cool. Yeah, I've seen people do that a few times. So yeah, that's fine. Elapsed, and we've got at least 10 responses, which is good. So let's come back in to the room, please. If you're still working on it, just go ahead and hit submit when you can. What'd you think of the 2 videos? Kind of silly, but decided to ask some more serious questions. Let's take a look at Google Forms instant analysis of answers. So looks like most of you, except one, were feeling good that Brian is claiming that Peter's so fat that he can exert his own orbit. Once objects get close to him, they'll fall into orbit. And the reason why he throws the object, a lot of you got at this, right? That you need tangential velocity. See a lot of reference to falling, which is great, right? The idea is that they're falling around Peter Griffin. So theoretically, if he hadn't thrown the apple, right? If Brian had just held the apple close to Peter and let go, if he's saying he has his own strong gravitational force, what would the apple have done if he hadn't thrown it sideways?
Wouldn't it just like land on Peter?
Yeah, would have just fallen right into him, like boom, right? Yes, and so that's why he's sort of tossing him sideways, and I guess he's getting it exactly perfect to match the curvature of Peter's roundness. So why is this technically a flawed argument? A little bit of confusion on this one, and so the correct answer is that everyone exerts their own gravitational force, right? Each of you is pulling on everybody else, right? Everyone in this classroom, we have gravity that is acting on each other, but it's so small and insignificant that we ignore it, right? It has no impact whatsoever. And so I guess this cartoon is just hamming it up and saying, well, it's so strong that you're actually drawing objects to yourself, which theoretically wouldn't be possible. And so the reason why it's not possible is if you do the math. And so I came up with some numbers, but got a lot of you, looks like just about half of you understood that. Anyone remember the value for G, the gravitational constant? I remember, what was it, times 10 to a positive number?
It was 10 to negative 11.
20. Yeah,
negative
10,
11.
10 to the negative 11. Who remembers, does that mean it's a big number or a small number?
Small.
That means it's a like unimaginably small number, right? 0.0000, 10 of those and then a number. So that's what sort of brings it into context in terms of newtons, right? That gravity is a very weak force, and you have to have masses that are huge, and no overweight person is ever going to achieve that, unless, like, again, Peter Griffin was suddenly very dense. It could do that, but not really possible. Rube Goldberg, I didn't know this, was a Pulitzer Prize winning cartoonist who drew a lot of silly cartoons. He drew these silly machines, didn't actually build them. I always thought he was like an educator or retired physicist. And it looks like, again, just a little over half of you didn't really know who he was, but some of you did. But I didn't know. It was interesting watching this video and looking this up for the first time. So, all right, any other questions or comments on that? Okay, I hate to be repetitive, but I have a little Canvas discussion that I want you to work on next. Once again, you're going to be watching 2 videos and answering some questions about them, but these are a little bit longer, a little bit more in depth, exploring orbit. So there's a link right there. This is task number 2 to the U4L17 satellites in orbit and gravity visualized discussion. And the instructions for what to do are at the very top of the discussion board. What you need to do is just read this over, hit reply on the bottom. You'll see there's already replies from all my other students, and just type your answers to the questions. So the first video is all about how we get satellites into orbit and how do we get them to stay in orbit. And there's 3 questions I'd like you to answer based on that. You might want to read them before watching the video, and then you can answer them as you go along or just afterwards. And then there's a video about what's called Gravity Visualized, which is actually a very popular video of teacher's demonstration of how he teaches gravity and getting at Einstein's idea of gravity and relativity. And there's 2 questions to answer about that. So you can number your answers, you can use bullet points, you can just write one long paragraph. It doesn't matter to me as long as you're answering the questions. So I'm going to give us about 20 minutes to work on this. Each video is about 5 minutes long in general. And I should say the second video, Gravity Visualized, it's 10 minutes long. I only want you to watch the first 5 minutes. Do not watch the whole video. Just watch the first half, 5 minutes of it, and then you can answer the questions. So again, I'll be here listening if you have questions, if you're not sure what to do. But otherwise, we'll time for 20 minutes, and then we'll check in again. Go for it. All right, kiddos, 20 minutes has elapsed. Let's come back together into the room. I'm seeing posts by about 8 of you, which is great. If you're not done, it's okay, don't worry. What you can actually do is just post anyway. So even if you haven't answered like the last 2 questions or something like that, I encourage you to just go ahead and say reply, like post your response, and that will save it. So that way you're not going to lose it as we move on to the next activity if you accidentally close the window. And just to show you on your discussion post, you can go back and if you look carefully on everyone's post, and including yours, opposite of your name in the other corner, if you look in the upper right corner, there's 3 little dots. It's kind of hard to see. When you click on those, one of the options you get is edit. And so you can then add to your answers. So it's just a nice way to still save your post, and you can come back to it. So if you're unable to finish this, we'll just roll over into homework. But I now want to move on to another activity. Before we do that though, just to reflect on this, hopefully those videos were somewhat informative. First video all about getting satellites up into space. What I found most interesting was what do they do with the old satellites, right, when they're dead? And you can either deorbit them, right, they bring them back down to Earth, they just let their orbit decay and they crash into the atmosphere, or they blast them upwards, right, they give them a little bit more tangential velocity and they send them into what was called disposal orbit. So how many of you felt that they should be deorbited? So see a little show of hands, like how many of you would deorbit your satellites? All right. How many of you would send them into disposal orbit? How many of you think we should just fire them up into space? All right, this class is kind of evenly split.
I said do half.
Do
like bring the like historic ones or like the important ones back down to Earth for like school and like research purposes, and then get rid of the ones that are insignificant.
Yeah. Yeah, and I think some are small enough too that they, even when they do crash into the atmosphere, like literally nothing is going to get through or hit the ground. So it's not like it's something we have to worry about. But he does make the point that even when you put a satellite into disposal orbit, does that mean it's never going to come back down to Earth again? And we catch on, like it will come back down, but how long from now?
We don't know exactly. It will just come anytime.
Yep, but most likely like years, it's going to be a long time. And so it's kind of funny to think that it could even be like 10 years. And so, if society falls apart or the apocalypse happens, even 10 years from now, there'll still be satellites that will be crashing back down to Earth. The other issue is that this kind of generates a lot of trash around our planet, right? Like, would you consider disposal orbit a form of pollution? Yep, some of you are nodding your heads. I think about it too. I mean, we don't think about space as an environment for us, but it is definitely somewhere we're exploring. And the other issue is that the more stuff we have floating around our planet, that poses problems for other satellites, right? If you've got trash floating around, but you have a working satellite that's going around, what's the problem? What could happen if you've got, stuff up there that we're not really paying attention to? And then you've got an important satellite like the Hubble telescope or something. What's the potential risk?
They could collide.
Yeah. Anyone see the movie Gravity with Sandra Bullock? If you haven't, you should go check it out. But the whole premise of that movie is that there's essentially an explosion in space. I think it's Russia is trying to dispose of one of their satellites, and it ends up accelerating all this trash into orbit around Earth. And so it's essentially this cloud of bullets that then destroys everything. So there's any space shuttles, any astronauts that are up there. And so she's trying to survive all that. It's a great movie. But that is something, it's a theory. It's never actually happened, but collisions with stuff, especially stuff that we've launched up there, could be a big problem. So great. All right, so now we are going to do an activity where I actually want you to do that demonstration that was in the most recent video, the one where the guy had the giant piece of fabric on the table. And so the fabric, you have to sort of understand, is representing space. And this is Einstein's idea of gravity. He didn't necessarily think of gravity as a force. He thought of it more as, if you've got this sort of what he called space-time, right? This relativity that everything is connected in some way, that large masses are bending that, right, towards themselves. And so we can use gravity, incidentally, to simulate this. So I know you guys don't have a giant spandex cloth at home, but I think I tried this at home and I was able to kind of make something simple. And so the instructions are on, this is task number 3. But what you're gonna need to do is get a pot or a pie pan or something large and round. Get like a t-shirt, like a running t-shirt that's made out of like the spandex fabric, or just a towel or cellophane, or even like a trash bag could work. You'll need some way of securing it, so you can use clips. I've seen clothing pins or butterfly clips if you have those, or if you've got a shoelace. There's a number of things you could use. And then you'll need something round, like a ball, a heavy one and a light one. That's the whole idea, right? The heavy one goes in the middle, the light one goes around the outside. However, you'll see in the video that I make, you can also just press into the middle with your finger, or even better, get like a knife and use the non-sharp end of the knife to just press down, and then you can easily get a ball to rotate around. So I have a whole demonstration video that you should watch, and then try it on your own. This is a Flipgrid assignment. There are 3 things I want you to film with your Flipgrid. One is just you pressing in the middle or having a weight in the middle and showing that when you let go of the smaller satellite, it falls to the middle, just like the guy did in the video. And then I want you to kind of throw your satellite sideways, like throw the marble to the side, just like you did in the video, and try to get at least 1 rotation. See if it'll go around at least 1 time, if not more. I found that the harder you press down, the more rotations you can get, or if you've got a nice small heavy object to use in the middle, that works well. And please just give a brief description of what's happening, right? You are simulating the bending of space-time by a larger mass that attracts a smaller mass, right? You have a satellite going around something much larger that's gravitationally attracted to it, and you're giving it tangential velocity to orbit around, and you're also just letting go to show the attraction. So again, instructions videos are all there. Here's the Flipgrid assignment. It's called Gravity Visualized. I have the same instruction video here, same instructions here. Again, I'm going to give us about 20 minutes to work on this. So we'll come back together at 1:20, which is, we're a little bit over time. But it's all right. We'll come back together right at the end of class 1:20. I'll just give you the homework assignment, and then we'll be good to go. So I'll be here listening if you need help, or if you're not sure what to use or what resources. But otherwise, I'll time us for 20 minutes, and we'll come back together. So go for it. All right, kiddos. 20 minutes has elapsed, and class is technically at an end, so I don't want to keep you any longer than I need to. So let's come back on in. Y'all have fun bending space-time? I know it's a little goofy when you're on a little tiny pot with a bunch of big clips on it and stuff, but
My mom was so confused.
Yeah. Hey, it's Einstein's idea. That's what you should just say. This is what Einstein was thinking. So, all right, I'll watch your videos. Your only homework is to finish any of these activities that we did. If you did not finish the answer the 5 questions or post your video, make sure you've done that. The only other thing is to please start reading Hewitt, chapter 28. Specifically 28.1 and 28.2. This is a chapter towards the end of the book, and I'd like you to answer the reading questions, which are at the end of chapter 28 on page 849. Please do the odds 1 through 9. Questions 1, 3, 5, 7, 9. Answer those in your notebook as we've been doing, and we'll review that when we meet again on Monday. All right, that is it for me, kids. Thank you very much. I would like to talk to Carmen and Rory, if you could hang out after just for a second about your quiz reflection or your midterm comment reflection stuff. Otherwise, everyone else is good. Thank you very much. Have a good one. But Carmen and Rory, if you could just hang out, please.
Thank you.